Here we are again with the latest news from the website prostatewarriors.com. And today we are welcoming you to a custom-tailored deep dive into the absolute cutting edge of prostate cancer research.
Yeah, it is a really exciting lineup we have today.
It totally is, because today's deep dive is heavily focused on clinical trials first. We're looking at how the medical field is basically trying to outsmart prostate cancer by, doing more with less.
Right, which sounds a bit counterintuitive at first.
Exactly. I mean, reducing those grueling side effects, overcoming drug resistance, and really personalizing therapies. And then later on, we'll transition into some pretty wild preclinical breakthroughs.
The preclinical stuff is, it's really setting the stage for the next decade of care.
Totally. But let's start with the clinical trials. Rethinking hormone therapy specifically, because if you're navigating advanced prostate cancer, you know that hormone therapy is the cornerstone of treatment.
Absolutely, it's foundational.
Right. But the side effects, I mean, we're talking fatigue, hot flashes, bone loss, they can be absolutely brutal. So the big question is, what if we could keep the efficacy, but just dial back the toxicity?
Yeah, and that brings us to the Enhance Phase 3 trial, which is, it's a massive UK trial involving about 1,500 men with metastatic disease.
Okay, 1,500 men. That's a serious cohort.
It is. And what they're doing is patients get their standard hormone therapy plus a blinded add-on drug. So things like abiraterone, enzalutamide, darolutamide, or apalutamide.
Right, the heavy hitters.
Exactly. But here's the catch. It's blinded, and they are testing a full dose versus a half dose.
Okay, let's unpack this. It's like watering a plant. If a gallon keeps it alive but drowns the roots, maybe half a gallon is the perfect sweet spot. We don't need to flood the system to get the job done.
That is a perfect way to visualize it. Because historically, oncology has relied on the maximum tolerated dose. Hit the cancer as hard as humanly possible.
Yeah, and just hope the patient can withstand the collateral damage.
Right. But if a half dose in this phase 3 trial gives the exact same cancer control, but the man gets to keep his energy and protect his bones, that completely rewrites the standard of care.
Which is huge for your quality of life. But, okay, tweaking the dose is one thing. What if we just change the entire hormone backbone?
Yes. The EQIP phase 2 trial.
Right. So in EQIP, instead of just changing the dose for men with hormone-sensitive disease, they take a totally different route.
Yeah, they do. So these men are receiving an RSI, an androgen receptor signaling inhibitor, but instead of these standard LHRH analogs, which, shut down the testosterone factory,
The usual suspect.
one cohort actually gets transdermal estrogen patches.
Estrogen patches, like applied directly to the skin.
Exactly. Applied on days 1, 4, 8, 12, and so on of a 28-day cycle. And what's fascinating here is the paradox of it all.
Tell me about it, because adding estrogen to fight a hormonally driven cancer sounds, I don't know, kind of risky.
I know, it sounds crazy. But when you use conventional therapy, you drastically lower a man's estrogen because testosterone usually converts into estrogen.
Ah, okay.
And it's actually that severe drop in estrogen that causes the terrible hot flashes and the bone loss.
So by giving them the estrogen patches, you're tricking the brain.
Exactly. The brain sees the high estrogen and naturally stops signaling the body to make testosterone. So you starve the cancer. But replacing the estrogen preserves bone health and stops the hot flashes.
Wow. Without feeding the cancer, that is just brilliant.
It's an incredibly elegant workaround, yeah.
Okay, so if tweaking doses or using these estrogen patches helps with the side effects, what happens if we just, stop the drugs altogether, like once the cancer is suppressed?
You mean taking a treatment holiday?
Exactly.
Yeah.
Let's talk about the EMBARK phase 3 trials, specifically this recent post-hoc analysis.
This one is really paradigm shifting for a lot of patients.
Yeah. So this trial looked at men with high-risk biochemical recurrence, meaning their PSA doubling time was 9 months or less.
Right, so aggressive, fast-moving disease.
Right. And these patients were on enzalutamide plus leuprolide. But the catch is, they suspended treatment entirely at week 37 if their PSA fell below 0.2.
They just stopped. Cold turkey.
Wait, if they stop the drugs and testosterone recovers to normal levels, which is the ultimate fuel for prostate cancer, why doesn't the cancer immediately roar back?
That is the million-dollar question, isn't it? Logic says it should explode. But the findings were amazing. About 3 to 4% of these men maintained a deep, long-term PSA suppression.
Even with their testosterone fully back.
Even after it fully recovered to eugenatal levels, meaning above 250 nanograms per deciliter.
That is wild. The fuel is there, but the cancer just doesn't ignite.
Exactly. It suggests that this finite, really intense early therapy creates a biologically meaningful reset. like a prolonged remission.
So for some of you listening, continuous systemic control isn't the only path forward. You might actually be able to take a break.
Right. It proves the concept that we can alter the disease dynamics long term.
Okay, but treatment holidays are amazing when the drugs actually work. What happens when the cancer mutates and standard therapies just, fail?
That's when we have to bring in the specialized molecular assassins.
I love that term, the assassins. Let's look at the GLR 2037 phase 1 trial.
Yeah, so this is a first-in-human trial for MCRPC and MHSPC. It's using an AR targeting PROTAC.
A PROTAC. Break that down for us.
Stands for proteolysis targeting chimera. Basically, it doesn't just inhibit or block the androgen receptor like standard drugs do.
Right, because standard drugs just kind of sit on the receptor.
Exactly. But this PROTAC triggers the receptor's ubiquitin proteasome-mediated degradation.
Here's where it gets really interesting. Traditional drugs are like putting a parking boot on a car tire so it can't drive. A PROTAC is like sending the car to the scrapyard and crushing it into a cube. It destroys the machinery entirely.
That is spot on. By completely shredding the receptor, the drug totally bypasses those frustrating resistance mutations. The cancer can't mutate a receptor that no longer exists.
Incredible. But, okay, if we aren't destroying receptors, what if we attack the cancer's metabolism?
Yes, the HITMAN-PC phase 1 trial.
Right. This trial is for biochemical relapse, and it combines hydroxychloroquine, or HCQ, and suliitraconazole,
An antimalarial and an antifungal.
which sounds like a very weird combo for prostate cancer.
It does. But they use it to disrupt lysosomal function and cholesterol trafficking. Cancer cells need a massive amount of lipids to build new cell membranes.
So they need fat to grow.
Exactly. And this combo essentially breaks their supply chain.
Okay, but let's look at the key data here because it's interesting. While no patients in this phase 1 trial saw a 50% PSA drop, which is usually what we look for, it stabilized the disease.
Right. Stabilization is still a massive win.
Totally. The PSA progression-free survival, or PSA PFS, was 5.5 months. And the time to ADT was pushed all the way out to 14.3 months.
Which significantly outperformed the natural history of the disease. Plus, they tracked 240 distinct lipidomic changes in the blood.
240 changes. So the drugs were definitely doing something on a molecular level.
Oh, absolutely. They were scrambling the tumor's metabolism, even if it didn't cause an immediate, huge PSA drop.
Okay, so that perfectly transitions us to the next big observational shift. If the HITMAN-PC trial proved that disrupting lipids and cholesterol matters, can we track those exact lipid changes in your blood to see if a drug is actually working?
We can. And this is where blood lipid profiles come into play. There was this fascinating Nature study recently.
Yeah, I saw that, showing that men with MCRPC have really distinct lipidomes, right?
Yes, they have exceptionally high levels of monounsaturated fats and long-chain phospholipids.
Like the cancer's just hoarding these specific fats.
Exactly. But when these men are treated with enzalutamide, those fats drop rapidly. It literally proves the drug is dampening the cancer's ability to build fatty acid-rich membranes.
So what does this all mean for you, the listener? Could you take a simple blood test and instantly know if your body is literally rebuilding cancer cells?
You absolutely could. The researchers actually identified a metabolic signature.
Like a specific marker in the blood?
Yes, high levels of a very specific sphingomyelin. It's called SM18.1/18.1.
That's a mouthful.
It is a very specific fat molecule, but having high levels of it acts as a signature of a favorable response to treatment, and it points to better overall survival.
That is amazing. Being able to read the tumor's diary just by taking a blood draw.
It's precision medicine at its finest.
It really is. All right, so let's move into our final section, the preclinical frontier. Because if we can read the tumor's metabolism in the blood, how can we test drugs on it before actually giving them to the patient?
This is where we get into custom clones, specifically TUR-P organoids.
Right. TUR-P, so transurethral resection of the prostate, just a standard procedure.
Exactly. Researchers are now taking the tissue from those routine TUR-P samples and growing mini tumors in a dish.
And the best part is no extra biopsies are needed for this, right?
None at all. They just use the surgical waste. And these mini tumors beautifully preserve the cancer's original mutations, things like TP53, PTN, APC, and FOXXA1.
It's basically a dress rehearsal. We take your exact tumor, clone it in a dish, and test the drugs on the clone first to see if it shrinks before we ever prescribe it to you.
Exactly. It takes the guesswork out of the prescription.
That is just mind-blowing. But looking to the future, how do we deliver these next-generation genetic therapies like CRISPR directly to those cells inside your body.
That is the ultimate delivery challenge. And it brings us to lipid nanoparticles, or LNPs.
Right, LNTs. We know them from the mRNA vaccines.
Exactly. They are great at carrying genetic payloads, but getting them into dense cancer cells is tough. So scientists found a way to supercharge them.
Just by adding amino acids.
Yeah, by simply adding a mix of 3 amino acids, methionine, arginine, and serine.
And the results were insane. mRNA expression increased 5 to 20-fold.
It's an incredible leap in efficiency.
Yeah, I mean, looking at the key data, in mice with liver injury, survival jumped from 33% to 100% just by adding those amino acids.
And for long CRISPR editing, the success rate jumped from, 20 to 30%, all the way up to 85 to 90%.
That is a massive leap. But there has to be a catch when it comes to cancer, right?
There is. This raises an important question. If we boost this cellular uptake in a non-selective way, especially in cancer, which has these really dense microenvironments, do we risk delivering too much of the payload to healthy tissue?
Ah, right. Because you want the CRISPR to hit the cancer, not the healthy cells next door.
Precisely. It's a thrilling hurdle, but it's the next big challenge for the future of cancer vaccines.
Wow. Okay, we have covered an unbelievable amount of ground today.
We really have.
Let's just summarize this incredible trajectory of research. I mean, we went from having standard doses and wearing estrogen patches to literally crushing receptors into dust with PROTACs.
And don't forget reading lipid diaries in the blood.
Right. Reading the blood lipidome and growing personalized mini tumors in a dish. It's just, it's a whole new world of oncology.
It really is. And, it leaves us with something really profound to think about. If we can grow your exact tumor in a dish, read its unique metabolism through a standard blood test, and use amino acids to slip CRISPR therapies past its defenses, are we moving toward a future where we stop treating prostate cancer as one broad disease and instead treat it as your highly specific, one-of-a-kind molecular footprint with a custom-built off switch?
That is a beautiful way to frame it, and that is exactly what this deep dive is all about. Thank you for joining us today. Stay strong and fight on.